Welcome back to the deep dive. Today we're confronting one of the biggest headaches in high-end AV installation. How do you get flawless, full-fidelity 4K video? We're talking 18 gigabits per second over distances where a normal HDMI cable just completely gives up.
Right, and that's the core problem. In these big residential or commercial jobs, you might have cable runs over 50 meters, maybe more. And trying to keep that 18 gig signal for things like HDR, well, it's basically impossible without some very specialized tech.
So that's our mission. We're unpacking the Blustream RX150CS HDBaseT Receiver. It promises to solve all this with, a single CK cable.
And the secret weapon in there, the thing that makes it all work, is something called CSC, color space conversion.
Okay, let's get into that. We know HDBaseT is the pipeline, but why is the CSC so critical for these really high bandwidth signals?
So what we're trying to push is 4K video at 60 hertz with 4.4.4 color. That 4.4.4, that's full uncompressed color, the absolute best you can get.
That's a ton of data.
A massive amount. So to squeeze it through the HDBaseT pipe for 100 meters, CSC very cleverly and temporarily shifts the signal down to 4.2.2 or 4.2.0 during the transmission.
Ah, so it slims it down for the journey.
Exactly.
Ah.
It frees up just enough bandwidth to keep that crucial 60 hertz frame rate and all the HDR data intact. Then the receiver just instantly rebuilt it at the other end.
That's fascinating. But okay, if you're relying on that kind of temporary compression and then reconstruction, isn't there a risk of, latency? Or maybe color banding over that full 100-meter throw?
That is the critical question, yeah. But the system is engineered to do that conversion so fast, we're talking microsecond level processing, that for the viewer, the latency is functionally zero. It's just a really elegant compromise to get the distance and the refresh rate.
And speaking of distance, those range limits are really the headline feature here. 4K, 60 hertz, 4.4.4, all the way up to 100 meters. That is some serious reach.
It really is. But what's great is the flexibility they built in. If you're only sending a 1080p signal, the device switches into its HDBaseT long-range mode.
And that gets you even further.
A lot further, up to an astonishing 150 meters. I mean, that feature alone could save an entire installation where the cables were run just a bit too long.
And what about other installation saviors? I'm thinking about the automatic downscaling. So you can send a 4K signal to an older 1080p display and it just works.
It just works. No handshake failure, no frustrating black screen. It just figures it out. But maybe the biggest win for installers is PC, power over cable.
Right. So the receiver itself doesn't need its own power supply.
No power brick at the display. It's all powered by the central matrix or the transmitter.
That simplifies cabling for sure, but what's the real-world benefit there?
Well, you're saving money on labor, and you have fewer points of failure, no cluttered outlets. The one thing you have to consider, though, is if you have, say, 8 of these running off one matrix, you need to make sure that central power supply can handle the load.
That's a great practical point. And it's not just video and power. They didn't skimp on audio either. We're seeing support for Dolby Atmos, Dolby True HD, DTS HD, master audio, everything.
Yeah, and that support is actually usable. It's not just in the spec sheet. The receiver doesn't just pass audio to the HDMI out. It has simultaneous audio breakouts.
The little 3.5 millimeter and the optical ports?
Exactly. An analog stereo and an optical toslink output. That's critical if you need to feed a soundbar directly or tie into a bigger building-wide audio system.
Then you add in the bidirectional IR, the RS-232, and the Ethernet pass-through. This thing isn't just a receiver anymore.
No, it really becomes an intelligent hub at the end of the line. It's power control, networking, video, audio.
All riding on that one table.
It's a textbook example of high-performance system integration. It just simplifies these incredibly complex, long-range setups.
So when you step back and look at it, Blustream had to use CSC, a form of temporary compression, just to handle 18 dBps over 100 meters. Makes you wonder, what's next? What kind of breakthroughs will HDBaseT need to handle the next wave of formats, like the 48 GBPs from HDMI 2.1 and beyond? Something for you to chew on.